The story of soap begins over 4,000 years ago, when ancient civilizations discovered that mixing animal fats with
Early soap was made from natural fats and alkaline ash, forming the foundation of a chemical reaction still used today.
From Roman bathhouses to medieval workshops, soap evolved from a luxury into a daily necessity.
The Industrial Revolution transformed soap from handcrafted bars into a mass-produced global essential.
Every bar of soap begins with oils and fats.
The second critical ingredient is alkali, most commonly sodium hydroxide, manufactured through controlled industrial chemical processes.
When oils react with alkali, a process called saponification occurs, breaking fats into soap molecules and glycerin.
Temperature, concentration, and timing must be precisely controlled to ensure consistent soap quality.
Glycerin, a valuable moisturizing compound, is separated and reused in cosmetics, food, and pharmaceuticals.
Modern soap production operates on an industrial scale, where thousands of kilograms of soap are produced every hour.
Unlike traditional batch methods, continuous reactors allow soap to be produced non-stop with precise chemical control.
Powerful mixers ensure oils, alkali, and additives blend evenly, preventing weak or unstable soap bars. Precise temperature and pressure control prevents incomplete reactions and guarantees consistent soap quality.
Automation and safety systems protect workers while maintaining continuous production efficiency.
After saponification, soap must be dried carefully. Too much moisture weakens the bar. Too little makes it brittle.
In spray drying, liquid soap is atomized into fine droplets, allowing rapid and controlled moisture removal.
Tiny droplets dry faster due to increased surface area, a principle rooted in basic thermodynamics.
Sensors continuously monitor humidity and airflow, ensuring every soap particle dries evenly. The dried product, known as soap noodles, becomes the base material for shaping and finishing. Soap noodles are now ready to be transformed into the solid bars we recognize. This stage defines the bar's density and structure. Inside the extruder, powerful screws compress and refine the soap, removing air pockets and ensuring uniform texture. Vacuum chambers eliminate trapped air, preventing cracks and improving bar durability. The extruder die shapes soap into continuous logs with precise dimensions. Automated cutters ensure every bar meets exact size and weight specifications. Embossing transforms plain soap into a recognizable branded product. Freshly shaped soap bars are still warm and soft. Controlled cooling is essential to lock in their final structure. Cooling tunnels regulate airflow and temperature to prevent warping, cracking, or uneven hardening.
As soap cools, its molecular structure stabilizes, forming a crystalline network that gives the bar strength.
Some soaps are cured for days or weeks, allowing moisture to redistribute evenly throughout the bar.
Hardness testing ensures every bar meets durability standards before packaging.
Before reaching consumers, every soap batch undergoes strict testing to ensure safety, consistency, and performance. pH testing confirms that soap is safe for skin while maintaining optimal cleansing power.
Mechanical testing ensures the bar will withstand handling and storage without crumbling. Foaming and lather tests gauge the soap's effectiveness and texture, key factors for user satisfaction.
Color and surface consistency are checked meticulously to maintain brand quality standards. Automated monitoring and record keeping ensure that every batch meets international safety and hygiene standards.
Once soap bars pass quality control, they enter the packaging stage, which ensures protection, branding, and market appeal.
Protective wrapping preserves moisture content, prevents contamination, and maintains the bar's shape. Branding adds visual appeal and helps consumers identify products, while batch codes ensure traceability.
High-speed cartoning systems streamline logistics, ensuring large volumes of soap reach markets intact. Packaged soap is stored strategically, ready for distribution to retailers worldwide.
Packaging combines protection and appeal, influencing consumer choice and reinforcing brand perception.
Modern soap production emphasizes environmentally responsible sourcing of oils and fats to reduce ecological impact.
Sustainable soaps use plant-based additives, reducing chemical load and enhancing biodegradability.
Energy-efficient technologies reduce carbon footprint while maintaining high production standards.
Modern facilities recycle offcuts, glycerin, and water, exemplifying responsible manufacturing.
Research and development in soap design meet consumer preferences while promoting sustainable practices.
Sustainable practices combined with innovation ensure that soap production remains both eco-conscious and consumer-friendly.
From ancient civilizations to modern households, soap is a cornerstone of personal cleanliness and health. Regular hand washing with soap prevents millions of illnesses each year, demonstrating its critical role in public health.
The soap industry produces billions of bars annually, connecting economies, jobs, and consumers worldwide.
From artisanal boutique creations to industrial staples, soap serves diverse needs and preferences.
Eco-conscious soap production ensures that cleanliness doesn't come at the cost of the planet.
Soap, a simple yet transformative invention, continues to protect lives, inspire innovation, and connect cultures globally.